last lab, last lab, last lab. Alright, sorry. We're going to do our last lab. I'm crazy. Alright, so I don't think you're going to need US. You don't have to install this. I'm just going to comment that out. But you do have to run this chunk to install car. And I'm just going to comment this out. We'll see if this works. And then, you might have to. I'm going to put this in the empty file, but I think you have to install ISLR. I thought you already did that, but you never know. Install, but you shouldn't have any issues because this is like not mine, so that's funny. All right, so I'm gonna go ahead and just run this right here. All I have to do is run this. Okay, sorry, press stop for some reason. Run this again. Okay, good. Now done. You can exit out of that. And so what we're going to do is work with, we're going to do or learn multiple linear regression or implement multiple linear regression in R, which is fine. It's fantastic. So when it comes to doing that, the data frame that we're going to work with, oh no, it's suggesting. Let me pause this. It's fine. I'll take that. It'll continue to suggest, but it's okay. Can't I turn this off? Oh, sorry, I'm learning something new. All right, so go back. All right, so here we're gonna go to college, and this is gonna allow me to gain access to the college data frame. So I'm gonna run this. Okay, I don't know why I'm getting that. Nothing shows up in my environment, but if I do structure college and I run this, okay, I can actually see the data, the actual variables within the data frame. For some reason it's not showing up in my environment. This is going to probably possibly happen to you, but if you type view college, you'll be able to see it as a data frame. Okay, you can see it as a data frame. So that's that. Okay, so good. You have the data. And the next big thing for us to be able to do is to select the variables that we're interested in. Well, so I know I said we're going to do simple and multiple linear regression, but we're going to first do simple linear regression. And I forgot what the variables we're going to look at. We're going to look at expenditure, like we've done in the past, expend. But then we're also going to look at top 10%. Okay. Alright, top 10%. So when I run this, I get SLR with the expand and top 10%. You may not necessarily know what top 10% is. Let's type that within our help. And I already knew, but I want to let you all know. It's a top 10%. It means the percent new students from top 10% of high school class. So those that are coming from top, their top class, what's the percentage of them that attend the university? And come to find out, this is real data, but from 1995. Whatever, you weren't alive then. What we can then do, once we select that information, select those two variables, we can then visualize this. Okay, with that, this is an interesting plot. They both show a positive linear relationship. This is the main one that we should consider, where x is going to be our top 10%, and expend is going to be our y, is going to be our response variable. And so we can get, we can say that there's at least a positive linear association. And then this is if we were to flip the x and y. Okay. So if I summarize the data, I get to see what is my min, my max, my mean, my median, my first and third quartile. So this is the 5-number summary, including just the mean. Okay, that's nice. And then from there, we can run our simple linear regression model. So what we can say is, what will be the response variable? Not like anyone's going to say anything to me. Expand, that'd be kind of weird. That'd be scary. Top 10%. So if this doesn't work, most likely you spelled something wrong. Or you didn't run the previous line. Okay, so when I run this, I now get my slope, my y-intercept, my r squared, my standard deviation of residuals, and that's about, and then you have your p-values, which is important. But that's pretty much it from the simple linear regression model. Okay, let's now run into the multiple linear regression model. Okay, the multiple linear regression model, we're actually going to select, let me look at my notes. We're going to look at acceptance, or expenditure, acceptance, top 10%, and student faculty ratio. Wow. My autocomplete really annoying. I don't know. I tried to turn it off, but it wouldn't turn off. Okay, expend. Accept. Top 10. And student faculty ratio. If I can type. I don't want grad rates. Okay, good. So when I run that, I go back to my environment. Okay, I'm getting an issue error. I have an additional parentheses. It's fine. I fixed it. Okay, so now from a multiple linear regression model, I have expenditure, acceptance, top 10%, and student faculty ratio. So what I'm going to do is I'm going to use these three explanatory variables to predict expenditure. But before we do that, let's look at the visualization. Visualize. Oh wow, interesting. So we can focus on the bottom left. So expenditure and accept has a positive. Expenditure in top 10% has a positive, whereas student faculty ratio, that makes sense. You're spending more money on students. Oh, well, there's more. That sucks. Where you're not spending as much. When you're spending more money on students, the student faculty ratio is going to be smaller because, like, private schools, you spend more money on the student, but then you have smaller classes. Okay, so there's going to be less students per faculty. Which is that makes sense. And so then that's relationship expenditure or accept in top 10%, accept and student faculty ratio, and then this is finally top 10% and student faculty ratio. This is interesting from 1995. We can summarize the variables to see instead of looking at these x-axes, and which is kind of hard for us to gauge. We can actually look at our numbers here. Okay. So I'm not going to spend time doing that. I'm just going to run this multiple linear regression model, expenditure. Now I'm going to do accept. I'm going to, top 10% per plus, why are you pressing commas? Student faculty ratio. Run that, and we have our multiple linear regression model. We have our regression coefficients, we have our p-values, we have our standard deviation of residuals, we have our adjusted r squared, that's what we're looking at, and we have our f statistic and our p-value. But in this class, and just for funsies, I'm not going to ask you a question, at least I don't think I'm going to ask you a question on this. I could ask you to plot the model. And if you do this, you can actually visualize the assumptions for multiple linear regression. This is the fitted versus residual. This is kind of a pattern. Alright, there's something going on here. So it dips down. This is the QQ plot. Okay. I don't know why that didn't work. And then this is the fitted versus standardized residual. That's for another assumption that we didn't discuss in class though. But this allows us to do the following chunk. Gives us the capacity to look at the model metrics in a deeper way. So we technically could have gotten the adjusted R squared 0.5725, which is this value here. They rounded up here. And then if I wanted the standard deviation of residuals, summary of sigma is 3,413, which is this value here. And then finally, the p-value that corresponds to test if at least one of the regression coefficients has a linear relationship with one of the explanatory variables has a linear relationship with the response variable. This p-value, you can run this, and that gives you that corresponding p-value, which is I'm surprised it's not giving us this exact value, but it's 1.4 times 10 to the negative 7. And then when I run the VIF of the model, let's see how this should give me technically, yeah, exactly, 3 different VIF scores. So if you remember, the VIF is measuring the collinearity between the explanatory variables. All these are less than 4, so they're not problematic. Not problematic. Not problematic. All right, this is the third cup of coffee for today. Hopefully that made you have a good time. You learned you experienced what we learned in class using R. So that's kind of cool. Makes me happy. Have a good day.